So guys, we're going to look at another concept on introduction to ordinary differential equation, and that is formation of ordinary differential equations. And what do you mean by formation of ordinary differential equation? This simply means we are going to derive a differential equation that expresses the relationship between a dependent variable and its derivative with respect to its independent variable. So here, a function will be given to us. Then we will be asked to form a particular order of a differential equation from that function. So our first example says use the function y equals cos x to form a second order differential equation. Subscribe to this channel for more videos on ordinary differential equations. Let's get started. So solution: y equals cos x. So it means you have to find the derivative of this, and that will give us dy dx equals negative sine x, because when you find the derivative of cos x, to give negative sine x. Let's continue. Now it says second order, so let's find another negative, this negative, then derivative of sine x is what? Cosine x. So this is what we have. Now let me write it in the prime form. We're going to get y prime prime equals negative cos x. So if that is true, let's look at this. Realize that but y is equal to cos x. So this means that we can replace y and cos x over here, and that will give us y prime prime is equal to negative y. And with this, we can group it to become this. So this is our second order ordinary differential equation. Since we've used the cosine, let's try that of the sine. So let's check this function, this. The same procedure. Our first derivative is cosine x. Our second derivative is negative sine x, but we know that y is equal to sine x, hence y prime prime equals negative y. Y prime prime plus y is equal to 0. That's very simple. So this is how you will be able to form a differential equation from any function given, and this is the second order because the highest derivative is what? 2. Now our second question says form a first and second order differential equation from y equals tan x. So let's look at that one too. So the second question says we should form first and second order differential equation from y equals tan x. Solution: so our y is equal to tan x. Our first derivative, whenever we differentiate tan of a function, it gives us second square of that particular function. To form the first order, we can choose to bring in the Pythagorean identity, because this one represents one of the Pythagorean identities. So we know that, but sec square x equals 1 plus tan squared x. So that means, this implies that y prime is equal to 1 plus tan x, tan square x, 1 plus tan square x. But we know that y is equal to tan x, and hence we can also say that y prime is equal to 1 plus y squared, and hence our differential equation. So very simple. What of the second order? Let's take the same function again. Our first derivative will give us sec square x. Now over here, let us not bring in that particular identity, but from here let's try and differentiate this again. So when we differentiate this, we are going to get these two will come, then we maintain the function, and function within function, the sec x, and that will give us sec x tan x. Why? We should note that sec square x is the same as sec x all squared, and this we're using the chain rule. Differentiate the whole function, so these two will come here, then we maintain this, and differentiate function within function, and that will give us sec x tan x. I hope it's clear. So that's why we're able to derive, or we're able to get this. Take note of that. So from here, y prime prime is equal to sec x will give us sec square x tan x. Over here we know that y is equal to tan x, and then y prime is also equal to sec square x. So we can substitute that straightforward, and that will give us, and hence we can say that y prime prime minus 2y prime y is equal to 0, and this is our differential equation. So as far as we are able to find relationship between the derivative of the dependent variable and the dependent variable with respect to the independent variable, that is correct. Our third example, form a first order differential equation from y equals x squared plus 1. So this is what we have. Solution: y equals x squared plus 1 power 5. So this, we can use the chain rule. Y prime is equal to, look at the process, differentiate the whole function, take the whole function as one function. So the 5 here will come, times x squared plus 1 minus 1 over here will give us 4, times function within function. This function we have to differentiate it again, and that will give us 2x. I hope it's clear. Good. So now let's simplify. Y prime is equal to 10x bracket x squared plus 1 power 4. Now we need to find the independent variable, and in here we need to create something to make it possible. So we can realize that, or we can see that this x squared plus 1, if you multiply that by the whole of this and divide by the same thing, so meaning we have to multiply by 1, something that will give us 1, and what will give us 1 is this one, x squared plus 1, x squared plus 1, because I have divided the same thing by itself, and that's the same as the one here. So if that's true, then I can multiply. Y prime is equal to 10x by x squared plus 1 power 5. For this one we multiply indices, that will give us that, all on x squared plus 1. So now this here, x squared plus 1 power 5 is the same as the y here. So I can say that y prime is equal to 10x y on x squared plus 1. I hope it's clear. So if that is true, now I can multiply this by that, the y prime on by x squared plus 1 equals 10xy. When I multiply through, I'm going to get x squared y prime plus y prime is equal to 10xy. So that's my differential equation. Simple. So we can see there's a relationship between the derivative of the dependent variable, and then the independent variable x. Very simple. I hope it's clear. Now let's go to the next example. Next example here says we should form a first order, second order, and third order differential equation from this. So that's what we have here. S cubed plus 5. So the first derivative, we're going to get y prime is equal to 3x squared. This y prime equals 3x squared. So for us to get the s cubed plus 5, so that we can introduce the y back into the function, for us to get our first order, here is squared, so we have to multiply both sides by x so that we can get the cube. So say multiply both sides by x, and that will give us xy prime is equal to 3x cubed. And again, add 5 to both sides just to achieve this. So if I add 5 to both sides, that's this side, I'm getting xy prime plus 5 is equal to 3x cubed plus 5. So let me split this so that I can get the x cubed. So xy prime plus 5 is equal to 2x cubed plus x cubed plus 5. So now it means this. Now it means that this is y. So but y is equal to x cubed plus 5. So if that is true, then you can say that xy prime plus 5 is equal to 2x cubed plus y. Exactly. So now let me try and group the derivative, the dependent variable, to one side. So xy prime minus y is equal to 2x cubed minus 5. So I can say that this is my first order here. My first order. Let's go to the second order. The second order. We need to differentiate again. And now you can see that for differentiating, you have to apply the implicit differentiation. So we maintain the x, differentiate the y prime, and that will give y prime prime. Plus, now we are going to maintain the y prime and differentiate x, and that will give us 1. That will create nothing. That will still be the same thing. Minus, when differentiate, we are going to get y prime. So by 1 y prime, but 1 times that is the same thing, equals 6x squared. This will give us 0. So now you can see this and this can go away. So xy prime prime equals 6x squared. So this is our second order. We can continue by forming the third order. The third order, the same implicit differentiation. Maintain this and differentiate this. This will be third order. Plus, now we are going to maintain the y prime prime and differentiate. That will give us this, equals 12x, and that's our third order. So that is that for the formation of